everyone, it's Mrs. Trombley. We are now starting Unit 3, Writing and Graphing Inequalities. First off, an inequality is a mathematical sentence that compares expressions. It contains the symbols less than or equal to, and greater than and equal to. To write an inequality, you have to look for the following phrases to determine which symbol to use. Alright, so you probably remember some of these from back in the olden days, I'm sure. This first symbol, this means less than. It's pointing at the number that is less. And if you see the words is less than or is fewer than, that's kind of a key that whatever number you have is going to be in front of that symbol. If you have a number that's greater than or is more than, this is the symbol you're going to use. I always use the crocodile or the Pac-Man wants to eat whatever's worth more. So if you see the symbol opened up towards, so it's open like it's going to eat the number, it means that that number is greater. Alright, if you see the words is less than or equal to, is at most, or is no more than, that means you're going to use the less than symbol with a line underneath. That means that it can be less than that amount or it can also be equal to it. And last but not least here we have is greater than or equal to, or if I said is at least or is no less than, that means that the amount in front of the symbol is going to be greater than or equal to that amount. Alright, so your first task here is to be able to take a number sentence that's written verbally and write it as an inequality. So we're going to use some of those keywords to help us out. It says a number W minus 3.5 is less than or equal to negative 2. Alright, first off, our keywords is less than or equal to. If you look over at your chart, less than or equal to is represented by that. And then what is less than or equal to? W minus 35 is less than or equal to negative 2. So this kind of serves as an equal sign, if you will. So W minus 3.5 just looks like this. We're going to use the inequality symbol here, and negative 2 goes there. Bam, that's all you have to do. Alright, number 2, twice a number k is at least negative 7/10. Alright, if you look at is at least over on your chart, is at least means that it can be equal to that, but that's the lowest it can be. So it means it's going to be greater than or equal to that amount. So twice a number k, twice a number means 2 times. And I don't want you to put the multiplication symbol, just write the number next to the letter like you always have done. And that's greater than or equal to negative 7/10 is what follows. Alright, one more of those. A number B is fewer than. So is fewer than, those are our keywords. And if you look over at your chart, is fewer than means the same thing as is less than. And it says that B is fewer than that. So we're just going to say B is less than 30.4. Alright, next. I know, don't you wish that was it? Sorry. So, solving inequalities. A solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution. The set of all solutions of an inequality is called the solution set. So there's some of your vocabulary lesson for the day. I know that some of those are on your vocab for this unit. Okay. So basically, inequalities can have more than one answer. So let's check it out. It says, tell whether negative 6 is a solution of each inequality or not. So if we're supposed to tell whether negative 6 is a solution, all you really need to do is plug negative 6 in and see if the inequality is true. I'm going to zoom into this. So I have 6 plus 4 is less than negative 1. Sorry, negative 6 plus 4 is less than negative 1, because we want to know if negative 6 is a solution. Negative 6 plus 4 is negative 2. Is negative 2 less than negative 1? The answer is yes. When you compare negative numbers, the higher the digit, the lower the value. So negative 6 works for this one. There are plenty of other numbers that would also work, but we're just testing negative 6. Alright, I want to see if it works for this one. So 5 minus negative 6 is supposed to be less than or equal to 10. 5 minus negative 6 is 11. Is 11 less than or equal to 10? Nope. So that means that negative 6 is not a solution to that one. Okay, and now I have 21 divided by x equals negative 3.5. 21 divided by negative 6 is actually equal to negative 3.5. And I know that negative 3.5 isn't greater than negative 3.5, but it is equal to it. And this means greater than or equal to. So either one of them is fine. That means that this is a yes. All right, turn your page. I'll move mine on over. Okay, so because inequalities can have so many solutions, we like to graph them so that we don't have to list them all out, because that would take forever. There's an infinite number of solutions to these things. So when you graph them, there are definitely some things you need to know. First off, when you go to graph this, you're going to be plotting a point on a number line and then kind of highlighting all the values that make this true. If you see a less than symbol, when you make your graph, you're going to use an open circle on the amount that you want to represent, because if something is less than that, it means that it can't be that amount. So for example, if x is less than 2, on here, x can't be 2, so I'm going to use an open circle on the 2. It can be all the values less than 2, though. For x is less than negative 1, x can't be negative 1, so I'm going to use an open circle at the negative 1. It can only be the values less than negative 1. And for this last one, sometimes you'll see it flipped around where the amount that I want to graph is on the right-hand side. What I would recommend that you do when you see this is rewrite it so that the variable is on the left. It just makes it way easier in the end, I promise. So I'm comparing x and 0, and if you see in this original one it's pointing at the x, it needs to continue to point at the x. So if x is less than 0, x can't be 0, it can only be all the amounts that are less than 0. And something that's kind of nice, if it's written so that the variable is on the left-hand side, this symbol points you in the direction that you need to shade on your graph. And that only works if the variable is on the left. So with this one, you see it's pointing that way, pointing that way. And when we rewrote it, it was pointing that way. So less than should always be shaded to the left. Less than left. You can remember that one. Okay, now when you're looking at amounts that are greater than and you're trying to graph them, again, we're going to use an open circle, because if the amount is greater than it, it means it can't actually be it. So if x is greater than 1, it means x can't be 1. It can only be the amounts greater than that. So I'm going to shade to the right, and this represents going on and on forever and ever in this direction. It can be any amount that's to the right of 1 on the number line. Okay, if x is greater than negative 2, it can't be negative 2, so I'm going to put an open circle, but it can be all the numbers greater than negative 2. And again, I have it flipped around. I have an x and a 2. I want the x on the left. It's opened up towards the x. I want it to continue to be opened up towards the x. X is greater than 2. Open circle on the 2. Shade to the right. Okay. When we have is less than or equal to, you're going to use a closed circle, because it can be less than the amount, but it can also be that amount. So you get to use a closed circle. And somebody in years past said that they look at that little line underneath as what fills in the dot, and this one doesn't have one, so it stays open. So if that helps, there you go. Alright, so if x is less than or equal to 0, that means that x can be 0, and it can also be any amount that's less than 0. So I'm going to shade all those numbers to the left, because less than means left. If x is less than or equal to 2, that means it can be 2. It can also be all the numbers less than that. And finally, of course, I wrote it opposite, so let's rewrite it. I'm comparing x and negative 1, and you see in the original expression here, or equation, that it's pointing at the x. I need to make sure that it's still pointing at the x. So x is less than or equal to negative 1. It means it can be negative 1 or all the values to the left. And again, you see that it's pointing you in the correct direction as long as you have the variable written on the left. Okay, and the last one of these is the greater than or equal to. Again, you're going to use the closed circle. That little line just fills it in. It means that it can be equal to it. That's why you're filling it in. So if x is greater than or equal to 1, that means it can be 1 or all the values greater. If x is greater than or equal to negative 1, that means it can be negative 1 and all the values greater. And finally, if 2 is less than or equal to x, that means that x is greater than or equal to 2. So we're going to flip that around to make it easier to process. And that means it can be 2. It can also be the values greater. Awesome. All right, so let's try a couple of these. If you want to, you could press pause right now, and you can try to graph the rest of these over here, maybe after we do the first one, so I can show you how to set up the graph. And then hit pause and come back to us and see if you did them right. Okay, so this first one says that y is less than or equal to -3. When you do your graph, I want you to have 3 points listed on here. The one in the middle, I want to be the number you're comparing y to, and then just fill in on either side. So if I was on a number line, -4 would be here, and -2 would be here. If you reversed those and put the -4 here and the -2 here, that would be a problem for sure. A correct number line would look like that. And remember, the higher the negative digit, the lower the value. So y is less than or equal to -3. That means it can be -3. And it can also be all the values less than that. For example, b. It says b is greater than -8. So in the middle here, I'm going to write the number I'm comparing b to. And on either side, I'm going to fill in a digit. So it should be -9 to the left, -7 to the right. If b is greater than -8, it means it cannot be -8, so I'm going to use an open circle. But greater means I'm going to shade all the values to the right. For letter C, g is greater than or equal to 1.4, so draw your line. In the center, I'm going to write 1.4. Now you might be thinking, what am I supposed to do here? Well, it's given to you where it's an amount in tenths here. I would just say, okay, 1.3, 1.4, 1.5. Just make sure that you're using equal increments no matter what you choose. So g is greater than or equal to 1.4. I'm going to use a closed circle because it means it can be 1.4. And it can also be all the values to the right because it's greater than. And last but not least, if r is less than -1/2, that means in the center here, I want to put -1/2. And I think I'll count by halves. So if I'm at -1/2 and I go down another half, that means I'm at -1. And if I go up a half, that means I am at 0. And if r is less than -1/2, I'm going to use an open circle because it can't be -1/2. It can only be all the values less than -1/2. This concludes our first lesson on inequalities. See you tomorrow.